All right, well, good afternoon, and thanks for taking the time to join my session today. As you mentioned, my name's Tracy Collins with EkkoSense. A little bit more about my background. So prior to joining EkkoSense, I worked for a company called Simple Helix, which is a regional co-location provider in Huntsville, Alabama. I was the CEO of that business. And then prior to that, I worked for Vertiv for over 21 years. Vertiv's one of the largest suppliers of critical infrastructure for the data center industry. So certainly I've spent my entire career in data centers, meaning I've lived through all of the challenges and limitations around critical infrastructure and IT load and how to get balance and operational efficiency out of that. So I'm really excited to join you here today and talk about what we've seen in the industry from EkkoSense. We've developed a software application that brings machine learning and AI to the operation of the data center, and that's not something that's common at this stage. Data centers continue on the operational side to do it the old way, but the new way is now available and is becoming the new standard. So we're going to talk about that. So as far as the agenda goes, I'm going to talk about why it matters, the data behind operating data centers and some of the things that you should be aware of, the current state of optimization within data centers, why it's important to gather critical granular data to use intelligence to the way you operate the data center, and where the divergence appears between operations and planning, typically because of the lack of visibility of what's happening. We're going to talk about where the real-time monitoring and visualization meets optimization, because that's really the next step for data center efficiency and operations. The steps that you need to take to successfully implement it. We will always have to talk about the value proposition. Is it worth doing? The business has to make a decision. The investments we make, whether it's budget or resources, are they justified by the benefits that we get? And then we're going to talk about how it's becoming the new standard. While we're at the early adoption phase of bringing this to data centers, AI and machine learning will take over the operation of the data centers, and I think we'll show that story clearly today. So first question is understanding why it matters. And before I talk about some of the statistics, let's talk about the data centers for a second. Data centers exist to support all of the infrastructure that the business needs to deal with everything that their customers and we need around data in the world. So it's comprised of compute and storage, networking and connectivity. The data center is the physical place that houses the hardware that all of that runs on. Understanding how to build that in a way that meets the needs of the marketplace, the needs of the business, today, tomorrow, 5 years from now, 10 years from now, is very challenging. It's not well done by most operators, and it needs to be well done by the operators. If you think about it, when you build a data center, 6 months to 36 months later, you'll start operating it. So you have to anticipate, what do I need 6 months from now? What do I need 36 months now? And that's just to start the journey. That data center that you build is going to operate for over 20 years. It's going to go through enormous change over that period of time, and you want to make sure that you stay optimized throughout the life cycle you're operating it, because if you don't, you're bringing two things to the table: risk and unnecessary cost. You're bringing other things too, but those two things every time. So getting it right is important, and you can't assume that your assumptions are going to get you there. You need to actually understand what's happening and stay in sync with the way you're operating it to meet the needs of the business. The most important thing a data center operator has to do is meet the needs of the business and their customers. Availability and uptime has to be 100%, and it has to perform to allow the experience to meet the expectations of the customers that they serve, both internal and external. The second most important thing is whether or not it does that efficiently. And what do we mean by efficient? Use as little energy as possible and cost as little as possible, because they are expensive to operate. The trick is you can't do the second if it harms the first. And yet the way data centers are operated today, that often happens. They're actually inefficient, and they bring more risk than necessary, and they're more expensive to operate because of the lack of visibility. So then the question becomes, does it really matter though? And the answer is, it sure does. Of all the electricity we use on this planet, 1% of it is consumed by data centers today. Think about that. That is a big number, and it's only getting bigger. The most conservative projections have data centers growing at 4.5% annually over the next 5 years. Some projections go over 20% because of everything that we're dealing with 5G rollout and just the things that we do as consumers and we depend upon every day, right? We can't possibly, I've only got 2 with me, we can't live without these things. And we're using them more and more every day, and we're expecting higher bandwidth out of them and higher performance than ever. So it's big and it's growing. A few other interesting stats. 35% of the energy in a data center goes towards cooling that data center, getting the heat out of the data center. So that's a big number as well. The way it's done today, 150 billion kilowatt hours per year are wasted through inefficiencies of cooling and airflow management in a data center. That's a lot of energy we're wasting. For them, as the operators, that translates to wasting over $18 billion a year. These are big numbers. An operator that implements an AI machine learning based solution to operate their data center will reduce the energy they consume around cooling and the associated costs by, on average, 30%. There is a big savings available and it can be experienced today. So the answer is yes, it does matter. These are big numbers. They're not particularly efficient. We've lagged behind other segments of the industry, but we can fix it. And we're on that path and on that journey today. So if you look at the way data centers are operating now, what you see on the screen is a representation of a typical data center. Where you see color that's the cooling units. That is where they're measuring and understanding what they're providing to the operation. All of the black racks that you see in there, that's the IT load. That's the server infrastructure, the compute, the storage, the networking, the connectivity. Most operators are blind to what's actually happening thermally and from a power consumption when it comes to the actual cabinets. And remember, those are the things that cause the need for the data center to begin with. In fact, our data shows that less than 5% of all data center operators actually measure what's happening at the rack level at that type of granularity. And if you're not doing that, you have no hope of taking advantage of the advanced technology that AI and machine learning brings to the table. So the operators are trusting that things are going the way they want. They're literally sticking their head in the sand, and they're hoping. And our research shows that 15% of the cabinets in the average data center operate outside of the ASHRAE standards for where they should be for optimal use of the equipment that's in those racks. That's a high percentage. That's risk. That's risk that they're taking on because of decisions they're making about what they're willing to look at. So if you think about it, everybody has this plan, and then reality hits, and there's a great divergence between the two. So what do I mean by that? What I mean is, we build to a set of expectations. We don't really measure whether or not those expectations are taking place. We don't always plan for things that are unforeseen, like using different types of server or storage platforms than we initially intended, and they require different overhead, different power consumption, power densities, all of those kinds of things. We had no idea that the company was going to go out and buy a business and say, we want you to roll their infrastructure into your operating environment, and it's completely different. I mean, these are real realities. So while I've got a plan and I maintain a plan, if I don't actually measure what's happening, I'm going to experience a divergence between that. How customers are trying to overcome that today is they use sampling. So they look at a few things and they hope that that represents what's happening. And they'll do periodic studies. They'll hire consultants or put a lot of effort behind going in and taking a snapshot, looking for problems, fixing it, and then going back to the way they're operating it. And that would make the same sense as if you were driving a car. You got on the road, you looked ahead, you said, I'm pointed in the right direction, I like the spacing with the other car, and then you closed your eyes for 10 seconds, and then you opened your eyes and said, am I still good? Yep, and I closed them for 10 seconds, and then you opened your eyes. You would never drive a car that way. You would always want to understand everything that's going on, what's happening, and course correct real time. And that's what you get from machine learning and AI. So the plan can be good, but as a famous man once said, Mike Tyson, everybody's got a good plan until they get punched in the face, punched in the mouth. And that's what happens in the data centers. All of those things that we talked about can happen. In fact, not only can they happen, they do happen. The standard is for things to go differently than we expected. And it's not good enough to hope and believe that what's happening is what's happening. And that's the way that customers or data center operators are doing it every day. That's the traditional way. The good news is the data is there. You can capture it. You can put sensors in every rack. You can put a $100 sensor in a rack and it will tell you what's happening. Now the data center operator might say, well, I got 1,000 racks, that's a lot of money. That's $100,000 you're asking me to understand what's going on. My answer would be, yeah, you're right, it's a capital expenditure. Now let's talk about the investment you've made in those racks. The server and storage infrastructure you put in those racks, on the low end is $20,000 per rack. On the high end, it can exceed $1 million of equipment you've got in there. Do you literally want to burn $100 bills to save pennies? Because that's what you're doing if you decide not to understand what's happening. That is where your investment is, and that's just your capital investment. If those things don't perform to expectations and that impacts your business and your customers, we don't even want to talk about what that impact can look like. So the good news is, if you put all of this in and you start seeing what's happening, now I see that data center floor. That's the same data center that was black before. I took the blinders off. Now I might not like what I see. When I see red in there, that means it's too hot. That's risk, that's problems. When I see that it's dark blue, that's not good, that's too cold. That impacts the equipment because heat is the enemy of electronics, right? Think of your car engine. If it runs hot all the time, two things are guaranteed to happen: failures, and eventually it'll stop working. Same thing applies to servers and the infrastructure in a data center. If it's too cold, you're adding humidity to the mix. Basically, that's water. Water and electronics don't mix either. You do not want human air running across the units to cool them. So those kinds of problems, you want to be able to address them. So the good news is now you got visibility. The problem is you might not like what you see. So think of making a plan to go to the beach, you jump in the water, and just as you're about to hit the water, you realize it's 35 degrees Fahrenheit. Oops, that's water, but that's not water I want to swim in. But as the saying goes, the path to recovery starts with understanding what's happening and admitting I've got a problem. And this is the start of understanding that. This is where AI and machine learning takes over and changes the game for operating data centers. There is so much data that is available. You've just got to capture it and do something with it. And what an AI and machine learning based system will do is it will measure everything. It will measure what's happening at the cooling units, what the UPSs are doing, and what the power that's being produced in there, what's actually happening at all the racks. And it will correlate all of that data real time and present that to you in an actionable manner. So the question is, well, why do you need AI and machine learning to do that? That data center I'm showing you right there realistically would produce over 40,000 data points a day that the AI machine learning will look at. And it's not just those data points, it's understanding the relationship between all of those data points and how they impact. What is causing what? What can I do differently and what will the results become? The AI and machine learning learn, they are constantly examining all of that data. They are learning how it's acting, they are learning what impacts what. And through that learning, they're able to determine, here is what you can do about it. So for the operator that brings AI and machine learning, they learn what's happening, they learn why it's happening, and they learn what to do about it. And as a result, they get to a more balanced state. That's what you want a data center to look like thermally. You want to see those greens and light blues, not the dark blues and the reds. So the AI-powered data center allows the operator to go to the beach with confidence, understanding that water's 60 or 82 degrees and I'm jumping in and I'm going to have a ball. In order to successfully take advantage of AI and machine learning in a data center, you've got to take certain steps. First, it starts, and I've talked about it already, you've got to gather the appropriate data at the appropriate granularity and persistently monitor it. The power data, the space, the cooling, because those are the constraints that you have in a data center. If you want to understand the relationship between them and optimize, you've got to understand them. Then you've got to present it to the operator in a visual manner, because as humans, what we don't do well at is looking at complex spreadsheets and trying to extrapolate what they mean. We need very easy to understand data so that we can learn and act appropriately. The analytics have to be built in. What is happening and does it provide actionable insights? Data without understanding is called noise. And there's too much noise that's out there, and that's the challenge in data centers historically that have been operated. There hasn't been a way to actually do something with that data that gives meaning and purpose and results. Delivering that into the operators in a way where the operators can still maintain control of the decisions of what they choose to do is important. Because sometimes the data will tell you should do something, but you know other things outside of the normal data set. For example, it's telling you make these changes, and you know, well, I'm about to actually deploy some new equipment in there that's going to change it. I wouldn't make sense for me to do that today because next Tuesday I'm making those changes. I'm going to wait to see what the data does after it. That's the human element, so empowering me to make the decision is important. And then probably the most important thing is doing it on an ongoing basis. You cannot optimize periodically and expect to stay in sync, right? Drift is natural. There is enough change going on in the data center environment that you want to stay in sync with that. The software is always looking for better ways to improve more and more. That's what machine learning and AI does. But it's also looking to make sure that as things change, that you don't drift and grow apart from an efficiency perspective. So doing that on an ongoing basis is important. So the question becomes, is it worth doing? You know, is the juice worth the squeeze, as they like to say? And that's important. You have to make decisions. Is it worth the effort to put into it, the budget and the resources? And they come at that from the view of traditional DSIM and monitoring solutions. They've been good solutions, they've helped, but they've also had problems. They are labor intensive from implementation throughout the lifecycle management. They provide limited information. Well, they can provide a lot of data, but limited information associated with that, and they will not help you optimize. So while they will do a good job when it comes to things like alerting, they won't actually help you improve the operation of the data center on an ongoing basis. AI and ML changes the game there. It takes all of those complex data sets, it crunches those numbers, it does in seconds what a human would take a week to work on and fail in the end doing. In seconds, it presents with actionable information that you can do. The deployment is fast. That data center that I showed you in that screenshot could be up and running in a number of days with everything orchestrated and up and running and showing you what's happening. Within days to a couple of weeks, it will have enough information built in that it will tell you, here's what you need to do about it, and you can fix it. The time to value and to measured value is days to a few weeks. The impact is really, really impressive. The average customer that deploys a machine learning based approach in the data center operations has an ROI of less than 12 months. Incredibly good payback. So, summarizing the critical things that AI machine learning is doing for data center operations: reducing risk, reducing energy consumption, releasing stranded capacity, up to 65% of the stranded cooling capacity, which means I can put more in my data center and operate it without having to build more data centers and invest in more cooling infrastructure. And doing this at the same time while lowering operating costs. And let's think about that for a minute. The value proposition here is I can reduce risk and lower operating costs simultaneously. That's usually the trade-off, right? How much am I willing to spend and how much risk because I don't want to spend more? Well, in this case, you lower both simultaneously. That's a crystal clear business case for anybody at a company that's making these kind of decisions. And then it does the other things. It alerts and notifies when problems happen. It's measuring things so granular it can actually show you failures are going to happen before they happen and let you proactively work them. And it's all about empowerment. The operator that has this kind of information presented to them in an actionable way makes good decisions based on data. They can see the results of that and understand the impact it actually had, and they're persistently optimizing in real time and able to report that to all stakeholders that are involved. So at the beginning I described that AI and machine learning would take over the way operations happen in data centers. It's already begun and we're just at the beginning, but that journey is going to go fast because they're going to lower their costs by 30%. They're going to remove risk. They're going to free up capacity and get more utility out of that big investment they've got. They're going to enable their team to have complete visibility operationally about what's happening. Lord knows the conference we just had in Europe and what that's all about. We can contribute here to lowering carbon footprint emissions through these kinds of actions, and all with an ROI of less than 12 months on average for the operator. The case is pretty clear, and that's why more and more customers are moving to it every day. So with that wraps up everything that I had. Here's my contact information if you want to connect with me on LinkedIn or email me. That's my cell phone number, or grab me after this session. Also, if you want to take a picture of that QR code you see up there, that's a white paper that we've developed, which is talks about how delivering proven machine learning and AI benefits for the mechanical and electrical space. I appreciate everybody taking the time to join me today, and I'll open it up if anybody has any questions or comments.